Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. First of all, in this cycle session of Fifth Broad International Symposium, allow me to thank for opportunity to present the article with the title Business Model Innovation of Off-Grid Public Electric Vehicles Battery Substation with Solar Power. The presenter for this article, I am Tubagus Alfiananda. As first author, I am from PT PLN Persero, and the corresponding author is Bu Vita Listianingrum PhD from Electrical Engineering Department Institute Teknologi 10 November. Next, I will explain for the introduction. Public battery substation or the abbreviation SPBKLU services are still dependent on the PLN power grid. So consolidated, they are still unable to suppress carbon emissions because the energy generated for the recharge of SPBKLU is still sourced from the mixed energy of fossil and renewable power plants. Purpose of this research, development of the SPBKLU business model that support energy transition program while analyzing financial feasibility of the business model developed. For the right side in this slide, you can see we use some article references. There are 6 references either from books or scientific works. Next, the literature review. According to IRENA, in the Indonesia Energy Transition Outlook 2022, electricity consumption could grow exponentially due to the impact of increased use of electric vehicles in the middle of the 21st century. This will be achieved when the government program of accelerating 15 million electric motorcycles is reached by 2030. By 2020, the Ministry of Energy and Mineral Resources has set a supply target of more than 10,000 SPBKLU in Indonesia. Regarding concept, the SPBKLU-based solar panels are almost the same as the solar power plant which use battery technology as energy storage with off-grid schemes. The difference is that the SPBKLU serves to recharge the batteries that will be used for electric vehicles, especially two wheels. We can see in the right side, on the right side for this slide, even though the actual achievement is now only 966 SPBKLU units that are already installed, and for SS condition, the SPBKLU still use power supply from PLN grid. Next, for the method, refer to this presentation title to design and analyze a new business model. We do first step. The first step, we calculate the need for solar PV for SPBKLU to determine investment cost. The second step, we use business model canvas or BMC as a tool to in management strategy to translate concepts, consumer, infrastructure, and company finances in visual elements. BMC is composed of 9 important elements. The third step, we do a financial analysis based on BMC and investment cost to get internal rate of rate or ERR, net present value, and payback period. And the last step, we do SWOT analysis to upscaling and sustainability business model. And we can see from this flowchart represents 4 steps that we already done for this research. Next, the result for investment costs, we can see on the right side in this slide, the SPBKLU contains 6 batteries. The calculation result is we calculate 10 solar PV with 500 watt peak capacity for each panel. And the SPBKLU needs solar start charge for each battery. And the total investment cost for SPBKLU with solar power is about 177 million rupiah. Next, the business model. The The first business model, we can name the battery provider, cabinet owner, and solar PV provider. We a bit abbreviation BPGSP. And the second business model is battery provider, cabinet owner, solar PV lease with the abbreviation BPGOSL. From these two business model, we can see the difference between these two business model in terms of cost structure and value proposition. Next, for the finance result of financial analysis between two business model, BPGSP and BPGSL, we can see the value of internal return rate, net present value, benefit cost ratio, and payback period. And we can from the calculation we can determine the swap rate tariff, where the BPGSP swap tariff is about 18,241 rupees, and the BPGSL swap tariff about 21,500 rupees. And we get the result that the current fuel cost for conventional two-wheel vehicle and the SPBKLU SS business model is still more economical than the BPGSP and BPGSL swap tariff. The reason why BPGSL and BPGSP swap rates still cannot compete with SPBKLU rates is use energy source from PLN grid. First, because at night the battery cannot be charged the SPBKLU. Then SPBKLU can generate revenue at night until morning. The second impact is of maintenance cost for solar panel. Next, for the SWOT analysis, we try to analyze and explore the strengths, weakness, opportunity, and threat. And then we can deliver the strategy how to upscale the business model. From this SWOT matrix, we can get opportunity to generate new revenue stream from carbon credit and renewable energy certificate issuance. Last, for the conclusion, BMC is a tool used in designing the BPGSP and BPGSL business models. The BPGSP and BPGSL business model are currently still unable to compete with the SPBKLU, which still uses the energy sources from the PLS grid due to additional investment or rental cost of solar panel. The results show the BPGSP business model swap rate is lower than BPGSL because the maintenance costs for solar PV are spared from the SPBKLU. From the SWOT analysis, SPBKLU with solar power has the potential to grow and generate a new revenue streams, example carbon credit and renewable energy certificate or REC issuance. Okay, that's all my presentations. I hope it's useful for developing the SPBKLU and solar PV business in the future. Greetings. Wassalamualaikum warahmatullahi wabarakatuh.